Congenial day, everyone. At this juncture, we will be discussing one of the rudiments of basic stoichiometry, the limiting reagents. But before anything else, let us first clarify what are reagents and what are reactants, as many students are confused with these two terms. Reactants and reagents are closely similar terms that are often used interchangeably in chemistry. However, it is important to note that there is a minute distinction between these two. Reactants are starting materials essentially consumed and undergo changes during chemical reactions. Reagents, on the other hand, are substances or compounds used to initiate, detect, examine, or observe the extent of a chemical reaction, among others. They aren't necessarily consumed in the reaction, but if they are, then they can be referred to as reactants. With that in mind, in today's topic, since reagents are consumed in the reaction, they will be referred to as reactants and vice versa. There are 5 salient terms that we need to remember to utterly understand this topic. These are the limiting reagent, the excess reagent, the percent yield, the theoretical yield, and the actual yield. Limiting reagent is a reactant that is completely consumed first in a chemical reaction, and thus limits the amount of product formed as the reaction cannot continue without it. On the contrary, excess reagent is a reactant that is not completely used up after a chemical reaction, or can keep reacting as long as there's still a sufficient amount of the limiting reactant left. Percent yield indicates how successful a reaction has been. It is the ratio of the actual yield to the theoretical yield in percentage. Hence, to get the percent yield, divide the actual yield, which is the actual amount of product formed after the reaction is complete, by the theoretical yield, which is the maximum quantity of product the given amount of reactants could form, and multiply it by 100%. For us to have an initial understanding of the concept of limiting reagents, let us take a look at this non-chemical illustration. As we can see, there are 5 hot dogs and 4 buns available. Out of this, 4 hot dogs in buns can be made with 1 hot dog in excess. Therefore, in this case, the buns are the limiting reagent, as all 4 of them are completely used up after being combined with hot dogs to make hot dogs in buns. On the other hand, the hot dogs are the reagent in excess, as after the said combination, there's still 1 hot dog left unused. Furthermore, 4 is the theoretical yield, as it is the maximum number of hot dogs in buns that can be formed out of the available materials or foods. Now that we've discussed the concept of limiting reagents in simpler terms, let us now proceed on solving actual stoichiometric problems concerning limiting reagents, which involves finding the limiting reagent, the excess reagent, the theoretical yield, the actual yield, and/or the percent yield. To find or determine the limiting and excess reagent, there are 5 easy steps that we need to follow. First, we have to write the given chemical equation in the problem. Next, we have to make sure that that chemical equation is balanced. Third, we have to convert the given quantity of the reagents into moles, if they are given in grams. Fourth, we have to divide their converted values by their respective coefficients based on the balanced equation to identify their mole per coefficient ratio. And lastly, we have to determine which reagent has a lesser mole per coefficient ratio. The one with the smaller mole per coefficient ratio will be the limiting reagent, whereas the one with the larger mole per coefficient ratio will be the excess reagent. Now, for you to better understand this step-by-step solution or procedure, let us try and employ it to solve the following stoichiometric problems.
For problem 1, what is the limiting reagent if 76.4 grams of tribomethane reacts with 49.1 grams of oxygen gas? First, we need to check if the equation is balanced. As we can see in the given equation above, the equation needs to be balanced. Balancing the equation would give us 4 moles of tribomethane reacts with 11 moles of oxygen gas to form 8 moles of carbon dioxide and 6 moles of water and 6 moles of tribomite. To find the limiting reagent, we need to convert the given reagents into moles by dividing them by their molar masses. 76.4 grams of tribomethane is equals to 0.286 moles of tribomethane, while 49.1 grams of oxygen gas is equal to 1.53 moles of oxygen gas. The third step is to divide the resulting value by their respective coefficient based on the balanced equation. 0.286 moles of tribomethane divided by 4 is equals to 0.07 moles of tribomethane. The second value, which is 1.53 moles of oxygen gas divided by 11, which is the coefficient of the balanced equation, is equal to 0.14 moles of oxygen gas. The one with a smaller mole per coefficient ratio will be the limiting reagent. Since the mole per coefficient ratio of tribomethane is smaller than mole per coefficient of oxygen gas, therefore, the limiting reagent is tribomethane.
For problem number 2, calcium carbonate reacts with 2 moles of hydrogen chloride to form calcium dichloride, carbon dioxide, and water. If 68.1 grams of solid calcium carbonate is mixed with 51.6 grams of hydrogen chloride, find the limiting and excess reagent. First, we need to check if the chemical equation is balanced. In this problem, the given chemical equation is already balanced. Now to determine the limiting reagent, convert the given reagent into moles by dividing them by their molar mass. 68.1 grams of calcium carbonate is divided by 100.088, which is equal to 0.68 moles, while 51.6 grams of hydrogen chloride is divided by 36.4578, which is equal to 1.42 moles. After converting the reagents to moles, divide them by their respective coefficients based on the balance equation. For calcium carbonate, its coefficient is 1, therefore 0.68 moles will be divided by 1, which is equal to 0.68 moles. On the other hand, for hydrogen chloride, its coefficient is 2, hence 1.42 moles will be divided by 2, which is equal to 0.71 moles. Now to determine which is the limiting reagent, we will compare the results of the previous solution. The one with the lower mole per coefficient ratio is the limiting reagent, while the higher one is the excess reagent. In this case, 0.68 moles of calcium carbonate is lesser than 0.71 moles of hydrogen chloride. Therefore, calcium carbonate is the limiting reagent, while hydrogen chloride is the excess reagent. After determining which is the limiting reagent, we will now calculate for the amount of reagent in excess, which is hydrogen chloride. So first, we will use the limiting reagent. 0.68 moles of calcium carbonate will be multiplied by the molar ratio of hydrogen chloride and calcium carbonate, which is 2:1, where 1 mole of calcium carbonate is in the denominator to cancel. Then to convert it into grams, we will multiply it by the molar mass of hydrogen chloride, which is 36.4578. This results to 49.58 grams of hydrogen chloride. So at the end of the reaction, 49.58 grams of hydrogen chloride will be used. Now to find the amount of reagent in excess, we will subtract the initial amount of hydrogen chloride, which is 51.6 grams, by the total amount used, which is 49.58 grams. We will have 51.6 minus 49.58, which is equal to 2.02 grams. So this means that for this problem, the limiting reagent is calcium carbonate and the excess reagent is hydrogen chloride with an excess of 2.02 grams.
Now that we're done with finding the limiting and excess reagent, let us now advance further in this topic by discussing how to determine the percent yield, which likewise involves determining the theoretical yield. For us to determine the percent yield, there are just 3 basic steps that we need to follow. First, identify the limiting reagent. Most of the time, the limiting as well as the excess reagent are already given in problems involving percent yields. However, if ever they are not given, then we can apply the 5-step solution expounded earlier. Next, we have to find the theoretical yield. So how are we going to do this? We can find the theoretical yield by likewise following 3 simple steps. First, convert the limiting reagent in grams to moles. Next, convert the limiting reagent in moles to moles of the product. And lastly, convert the moles of the product to grams. The resulting converted value will equate to the value of the theoretical yield. Once we've identified the theoretical yield, we can now find the percent yield by dividing the actual yield, which is often already given, by the theoretical yield and multiplying their quotient by 100%. Again, for you to better understand how to determine the percent yield, let us take a look at the following sample problems and solve them using the discussed step-by-step solution.
For problem number 3, a reaction between aluminum hydroxide and hydrogen chloride gas produces aluminum chloride and water. The actual yield of aluminum chloride for this reaction, in which 15.6 grams of aluminum hydroxide is reacted in excess hydrogen chloride gas, is 24.67 grams. What is the percent yield of aluminum chloride for this reaction? First, write the chemical equation of the reaction and make sure it is balanced. The balanced equation of the reaction is 1 mole of aluminum hydroxide reacted with 3 moles of hydrogen chloride gas to form 1 mole of aluminum chloride and 3 moles of water. Now, to find the percent yield of aluminum chloride, first, determine the limiting reagent. In this problem, since the aluminum hydroxide is reacted with excess hydrogen chloride gas, then the limiting reagent is aluminum hydroxide. Next, find the theoretical yield. To find the theoretical yield, first, convert the grams of the limiting reagent to moles by dividing it by its molar mass. 15.6 grams of aluminum hydroxide is equal to 0.2 moles of aluminum hydroxide. Next, convert the moles of the reagent to moles of the product by multiplying it by its molar ratio to the product. The molar ratio of aluminum hydroxide to aluminum chloride based on the balanced equation is 1 to 1. Make sure that the ratio of the reagent is in the denominator to allow cancellation. 0.2 moles of aluminum hydroxide is equal to 0.2 moles of aluminum chloride. Now convert the moles of the product to grams by multiplying it by its molar mass. 0.2 moles of aluminum chloride is equal to 26.67 grams of aluminum chloride. The theoretical yield for the reaction is 26.67 grams of aluminum chloride. Lastly, find the percent yield. The formula for percent yield is actual yield divided by theoretical yield multiplied by 100%. 24.67 divided by 26.67 times 100% is equal to 92.5%. The percent yield of aluminum chloride for this reaction is 92.5%.
Problem number 4. Sulfur reacts with aluminum to form aluminum sulfide. If 4.8 grams of sulfur reacts with excess aluminum to form 4.5 grams of aluminum sulfide, what is the percent yield of aluminum sulfide for this reaction? First, write the chemical equation of the reaction and make sure it is balanced. The balanced equation of the reaction is 3 moles of sulfur reacted with 2 moles of aluminum to form 1 mole of aluminum sulfide. Now, to find the percent yield of aluminum sulfide, first we need to determine the limiting reagent. In this problem, since the sulfur is reacted with excess aluminum, then the limiting reagent is sulfur. Next, find the theoretical yield. To find the theoretical yield, first, convert the grams of the limiting reagent into moles by dividing it by its molar mass. 4.8 grams of sulfur is equal to 0.15 moles of sulfur. Next, convert the moles of the reagent to moles of the product by multiplying it by its molar ratio to the product. The molar ratio of sulfur to aluminum based on the balanced equation is 3 to 1. Make sure that the ratio of the reagent is in the denominator to allow cancellation. 0.15 moles of sulfur is equal to 0.05 moles of aluminum sulfide. Now convert the moles of the product into grams by multiplying it by its molar mass. 0.05 moles of aluminum sulfide is equal to 7.5 grams of aluminum sulfide. The theoretical yield is 7.5 grams of aluminum sulfide. Finally, to find the percent yield, divide the actual yield by the theoretical yield and multiply it by 100%. 4.5 divided by 7.5 times 100% equals 60%. The percent yield of aluminum sulfide for this reaction is 60%.
Knowing how to calculate or solve for the limiting reagent or reactant is salient, as it can help a person, most especially a chemist, predetermine the maximum amount of product a particular reaction can form based on the quantity of reactants at hand. Thus, it can also help him or her have near accurate expectations and or gain needful ideas concerning what actions or adjustments he or she should do in order to meet the desired or ideal amount of product. Furthermore, limiting and excess reagents or reactants are among the basics or rudiments of stoichiometry. Hence, having a decent understanding of this topic could serve as a good stepping stone toward advanced stoichiometry. That is the end of our discussion. Thank you so much for listening and have a nice day.